Okay, go.
Okay, so this is number 6 on the 2014 AP. This is the last one, and it's a slope field. Now, on part A, they asked you that a portion of the slope field, the differential equation, is given below. And making sure that you realize that a portion of the slope field of the differential equation, making sure that you know that this is for the derivative. This is the graph of the derivative, not like the actual graph itself. That's very important. So they said sketch the solution of the curve through point 0, 1. We know that when f is equal to 0, it's 1. So what we decide to do is we plug in 1 for y and 0 for x. So we have dy and dx is equal to 3 minus 1 of cosine of 0. And that ends up giving us 2. So we know then, at this point, which is 2 right here, that there's going to be a positive slope. And then from there, we can sort of look at the graph and say, okay, well, we know about cosine of x, where we know when it's, inverted and multiplied. And so we see, basically, if you give a rough approximation that's close enough, they won't mark you off if, a tick mark was right here and it should have been right here. So what the graph ends up looking like then is something like this. You're coming down, and this is a little bit more steep. So making sure you're looking at the line. So this doesn't have to be exactly like that. So the reason why slope fields are actually a little bit easier in this way is even if you don't know exactly what the graph looks like, just by looking at which way the slopes are going or exactly which way the tick marks are, you can sort of get a rough idea of, okay, maybe I should try plugging in these points. So that is essentially part A. So that wasn't too bad. Then we have to move on to part B, where you basically have to write the equation for the line tangent to the solution of the curve. So you actually don't have to do very much work if you know what they're asking for right here. So for part B, when they ask you to write the line that's tangent, you just have to say, okay, you have to realize that dy dx is going to be your golden ticket here. So when you have B is equal to dy dx is equal to 3 minus 1 of cosine of 0, that's 2. Okay? And then you say, okay, if y minus 1, because remember we have the point 0, 1, is equal to 2 times x minus 0. That gets you the solution, y is equal to 2x plus 1. From there, all you need to do is plug in 0.2. So y is equal to 2 times 0.2 plus 1, and that'll get you y is equal to 1.4. So that really isn't too bad. That, as long as you understand the jargon they're using, then, you can get that done in a minute. Then part C, that's the real, difficult part here. That's the problem that a lot of people had to just think a while and they weren't quite sure if they had it right. So, to begin tackling this beast, what you have to do is say, okay, we know that C, dy dx is equal to 3 minus y cosine of x, and that f of 0 is equal to 1. So we know those things. So what we're going to do is we're going to transfer 3 minus y to this side and d of x to this side. So we eventually get d of y over 3 minus y is equal to cosine of x, d of x. Then you want to take the integral, because we're finding when y is equal to f of x. So that's like the primary function here. So we find the integral from d of y over 3 minus y is equal to the integral of cosine of x, d of x. So then you have natural log of 3 minus y is equal to sine of x plus c. Okay? And it's important to keep the plus c here because sometimes it's a little ambiguous as to if we need it or not, but we really only just need the c here in order to find exactly where the equation we need, what the equation we need. So from this point on, we can say, let's see, there's actually another important part here. When you create a natural log here and you have 3 minus y, you have to think about what's the outcome when we derive that. And what it would be is 3 minus, or negative 1 over 3 minus y. But obviously this function isn't negative, so we have to put a negative here to sort of counteract that. So then what we eventually get is the natural log of 3 minus to the negative sine of x minus c plus 3. And according to the rules of just putting anything to the e, we can bring the c right in front here. So it's important to review those rules before the test. So c is, times e to the negative sine of x plus 3. Okay, and it's now positive because you have negative times negative c. Then what all you have to do from here is, pretty easy in retrospect. So you plug in 1 is equal to c to the e negative sine of 0 plus 3. Okay, and anything to the 0 is 1. So 1 is equal to c plus 3. So c is equal to negative 2. From there, you can plug that into c. So y is equal to negative 2 e to the negative sine of x plus 3. And that's your answer. So just to keep in mind, whenever they give you something like this, it may take a little while to get there, but they're going to give you like numbers to plug in that don't require you to think about, oh, what's the decimal going to be? It's going to be straightforward so you can get this nice answer. Great, so that's number 6.